All right, dear students, welcome to your measurement series. We're going to have a few lessons on measurements, and you're going to notice that this topic is a lovely one, a very easy topic to start with. So this lesson is going to be more of an introductory video. It's going to check on the things that you already know, you are expected to know at this level. So firstly, let's talk about the area of basic shapes. Okay, so you need to know the area of, let's say, a square right here. You're noticing that you just have to say side squared, where the side is the length of each side of a square. You know that a square has got equal sides. And then if you go to a rectangle, notice the rectangle is a longer side. One side is longer than the other, so we call that one the length, and then the other one we call it the breadth. So if you would like to calculate the area, we just multiply the two, really, just length times breadth. It's that simple over here. So that is what you get for the area of a rectangle. We also had a triangle, and for the triangle we would like to mainly talk about the perpendicular height. You have to understand that when we say height here, we'll be talking about the perpendicular height. There's got to be two sides that are at 90 degrees to each other. So this one right here will be the height if that one is the base. So the area of a triangle is going to be half base times height, as we are noticing over there. We already know these things. These are the basic shapes that we know. And let's not forget a circle. How can we forget a circle? We learned that one as well. And this one, we just say pi r squared. I'm just noticing now that I didn't give you a trapezium. So please, if you have a trapezium, normally a trapezium looks like this. I'm going to just draw it somewhat this way. And then these two sides should be parallel, and the parallel sides are the ones that we call A and B, and normally this height here is the one that we call H. If you'd like to calculate the area of a trapezium, it's half A plus B, which is the sum of parallel lines multiplied by their height. These are the basic shapes that we normally use. Everything else that we're going to do when we have a bigger shape, such as prisms that we talked about back then, we use the basic shapes to calculate the area of such prisms. So why don't we start with prisms in this lesson, and then we discuss the prisms that we already know, we have seen before, but we want to see if you remember those ones. Right? So that's a rectangular prism, my first one over here. So on a rectangular prism, don't forget you have the length, there will be the breadth, the length is the longest side, and then this part here will be your height. So if you would like to calculate the total surface area, because it's a prism now, it's made up of many faces. As you can see, this one on our first example has got 6 faces, but these ones are just basic shapes, and they are actually rectangles, 6 rectangles that we have to talk about. So how do we actually calculate the total surface area of this one? Please notice we just calculate one surface after the other. So let's see if you can follow. I'm going to calculate these two sides, that is this side here and that side over there. As you can see, I'll have to say length, this length here, length, and I have to say height as well. So if I want those two sides, that's what I'm going to do. So I have 2 of those. That is length times height. Okay, so I'm done with those 2. I would like to calculate the side which is at the bottom. You see that bottom side, just that one, and then the one on top, just this one over here. So we want to calculate the area of those ones. And well, there are 2 rectangles, and to calculate the area of such a rectangle, you have to use this side and also this side. So it will be length times breadth. Okay? And then, lastly, we still have to add, you see those pink sides of ours, that is this side and that one over there. If we want to calculate the area thereof, you can see that they're the same. You have to use this side, which is the breadth, and also the height. So you have to say breadth times height. So from what we are gathering, if we would like to calculate the area of this thing, we have to just say 2. Notice we have length times breadth. I picked the second one. Plus 2, then I picked this one, right? Let's have this one next. Breadth times height, and then plus 2 times the first one, length times height. like that. So if you would like to calculate the total surface area of a rectangular prism, this is what you're going to do. And please, people, how is it that we know that something is a prism? In case you have forgotten, please, it has a cross-section, a cross-sectional area that will be at the bottom. In this situation, it is this area here. Can you see it's a rectangle? Even on the other side, you can see that it's a rectangle as well. Then if we have the same shape at the bottom as we have on top, we say that we have a prism. So a rectangular prism is one example of such prisms. Okay, you will notice that some shapes will have a circle at the bottom and a circle on top. That will be called a cylinder. And then if you have a triangle at the bottom and a triangle on top, then we call that one a triangular prism. Those are the prisms that we are interested in at this level. All right, good. Let's calculate the area of this one over here. Let's make substitutions and see what's going on. What is the length of this thing? Remember, the length is the longest side. At this point, it appears like it's this one, which will be 7 units. You see, that will be 7 right there. It's given. Well, what is the breadth? And in this situation, the breadth is 6. And then let's go and substitute. The breadth, we said, was 6. What about the height? Well, notice the height is just 3. So you make your necessary substitutions and you carry on. The length is already 7 and the height is 3, so you just leave it over there. So this is your calculator's job. Make sure that your calculator gives you the correct answers here. Okay, I am getting 162 square centimeters. It's important as well at this level that you check if the units are the same as well, because at times you may be given units that are not exactly the same. In this situation, they were all centimeters, so I'm good to go. That's actually what you do with a rectangular prism. It's nothing serious, really. All you have to do is to make this formula. You don't even have to memorize it, as you can always do it when you're asked. In fact, if they say that it's an open box, what you will just do is to make sure that you have one only here. Instead of having 2 here, you will only have just length times breadth without a 2, meaning that one of the surfaces has been taken out, the top surfaces. Remember, you get it by saying length times breadth. Those are the 2 sides that's the shape you would have taken away. All right. Let's see what else we have on these prisms. As you can see, we also have a triangular prism here, and a triangular prism, like I've already said, notice the cross-sectional area here. Can you see that it's a triangle this side? Even on the other side, you can see it's a triangle. So because this shape has got triangles at the bottom and at the top, we say it's a prism, and we name it using that cross-sectional area, which in this situation is a triangle. So it's a triangular prism. So if you would like to calculate the total surface area of a triangular prism, all you need to do is to see which shapes are making the prism. In this situation, you can see that you have 2 triangles that are identical in this situation. So if ever you want to calculate the total surface area here, you know you will have to calculate the area of 2 triangles. So it's 2 triangles, and depending on the type of triangular prism you have, the sizes of these rectangles that you're seeing will change. So in this situation, the rectangles that I'm looking at this particular example, you can see that there is this rectangle here, which is a very big rectangle. We have to calculate the area of that big shape which is on top. So you have 2 triangles, then a big rectangle. Then you also still have to calculate that rectangle over there. I hope you can see it. It's on the other side, that one. Do you see there is a rectangle that goes on like this? So you still have to calculate the area of that rectangle. It's not as big as the one there. And then lastly, please notice we have another rectangle here at the bottom. So again, it has got its own area as well. So it does look like you actually have to calculate all these. So if you're calculating the total surface area, if you know how to calculate the area of a triangle and the area of a rectangle, it means you're sorted for this one. So what do I mean here? Let's go and try to answer the example that we've got here, because this is definitely not a formula. I don't believe in keeping a formula in your head so you can use it after some time. For these things, you just need to know the area of the basic shapes, and then you use your basic shapes to get to what you want. So let's go ahead and solve this problem that we have. We have a triangular prism. Luckily, we have the perpendicular height of these triangles that we are supposed to calculate. You know that to calculate the total surface area, we will definitely need to calculate the area of two triangles. So from what we know, the area of a triangle is half base times height. So let's just write that one down. So this will be for the triangles, this part here. Well, then we have a rectangle, which we talked about. You can see that we still have that big rectangle here on top, this one right here. We will have to calculate the area of this one. So to calculate the area of that one, I'm going to say length times breadth in blue. Let me call it L1B1. So that's the first rectangle I want to talk about. The second rectangle I want to talk about is this one on the other side. That one, you know that I'll have to calculate the area of that rectangle. So I'm going to call it my L2 times, you know we say length times breadth, right? Times B2. Then I have to add the last one. The last one will be the one at the bottom. I will have to calculate the area of this rectangle here at the bottom. So I'll call that one L3 times B3. Okay, so far so good. Let's see what to do with substitution. All you really have to do is to make sure that the units are the same first. In this situation, there was a small trick. Notice we are supposed to calculate the area in square centimeters, but our question has got millimeters over here, and it has got meters over there. Everywhere else, these units are fine. I prefer that you change the units at the beginning, before you calculate the area. So you can use this table here that I gave you. If you calculate the area using let's say meters, when you are asked to change it to square centimeters, it requires more work, some more conversions have to be done. So it's better you convert these things now when you are still able to do it. So let's first of all convert this 0.03 meters, right? Using this table that we've got here. Notice if you have meters, you are at this point, and you want centimeters. It means you are going 10 times 10. 10 times 10, it's 100. It means you multiply. Do you see this side? If you're going this side, you multiply. You multiply whatever you have by 100 or times 10 times 10. That way you get to what you want. That is how I'm going to see that this is equal to 3 centimeters actually. Well, come again. We have millimeters here on the height. So from millimeters, here I am, I would like to go to centimeters. I think you're noticing that I have to go this way, isn't it? So I have to divide if I'm going this way. So this way, you are noticing there's a division sign here if you're going that way. So if you're moving from millimeters to centimeters, you divide by 10. In fact, there are 10 millimeters in every centimeter. So here we can tell these are just 2 centimeters that we are going to use. So if you do your conversions early, you avoid being disappointed later. Let's go ahead and calculate the total surface area here. Okay, 2. On the triangles that we've got, I hope after I've done all that, you can still see your triangles, the 2 triangles that we've got. Luckily for us, for these 2 triangles, we are going to use a base of 0.03. If I use a base of 0.03 meters, which we changed to 3 centimeters, look at me. We changed that base to 3 centimeters. Okay, so I'm using 3. Can you see that the perpendicular height then will have to be 2 centimeters? If I use this side here at the bottom, which is 3 centimeters long, the perpendicular height of these triangles will then be 2 centimeters. So there isn't much highlighting we can do. let's try. Maybe you'll be able to see. Do we have one? So we are saying if we use this part here, the perpendicular height should be that one. I don't like the highlighter. All right, so here we are. That's what I mean over there. So let's see what we can do about things here. Right, I'm going to make substitutions now. Let's get the correct pen. Right, on the triangle, this one that I colored blue, the rectangle I colored blue, I think you're noticing that its length is 6, it's in centimeters, and its breadth is 4. Easy to see. Look at the one that I highlighted red, which is this one right here. I want the area of that one. As you can see, I'll have to use the length. This will be the length this side here. So as you can see, the length will be 6 as well. And then you say multiplied by 2.5, because 2.5 was given to us there in centimeters. And lastly, the one at the bottom, this rectangle here. So the length I'm using should be 6, and this right here will be the breadth. So it's 6, it's going to be 6, and we changed that one to 3 centimeters. So that is what you do there. I think now this is just your Casio or whatever calculator you use. It can take care of this in one step. I'm pretty sure it can. So go ahead and do it. Okay, you should get maybe something like 63, or maybe tell me if this was correct afterwards. It's very difficult to work with these calculators here. Okay, good. That will be 63 square centimeters. That should be a correct solution for that one. So you see, that's what you do with prisms. So far we talked about the rectangular prism. We talked about the triangular prism. Well, let's appreciate the fact that we still have yet another prism that we know, and that would be actually the cylinder. But before we do that, I'm noticing that we have to answer this question. Let's answer this question first. In fact, why don't you do it on your own first? Prove to me that you know this. Pause and do it. Well done if you got your solution for this. So we are want to determine which container here will be the least expensive, or will be less expensive to wrap, since it's just 2 of them. Okay, good. So if we are going to wrap these containers, it means all surfaces are included. There is no such thing as, oh, it's an open box, so I'm leaving out another surface. No. For the rectangular prism, which you're noticing here on the left-hand side, every face will be included. So I hope you still remember how to calculate the total surface area of this. So let's hear from you. I said you say 2 multiplied by, you'll be calculating this one, the top and the bottom. So if you calculate the top and the bottom, notice you have to use length and breadth, isn't it? So it's 2 times length times breadth. It's 6 of them, right? And then you have to calculate these ones that are on the side. So I'm saying these ones. So you have to use this side and that side if you want to calculate this one, because then it's 2 of them and that one as well. So notice you have to use the length and the height, isn't it, people? So it's 2 multiplied by length times height, unless, of course, if you just remember it on your own, the formula. And lastly, we have to calculate the area of these faces here, this face here, this one, and of course its friend over there. So this one is the breadth and the height, and it's 2 of them. So it's 2 multiplied by breadth times height. Let's not forget the formula. In fact, we don't have to, if it's easy like this one, you can keep it. However, I prefer you make it all the time you do this. Well, the length of this one, let's first of all see if we are going to be tricked by the units. It's actually the same unit all through. It's centimeters, so I don't have anything to worry about. I'm just going to substitute. So it's 16.5 multiplied by 14 for the first one. And then for the second one, the length is still 16.5, but the height is 2 centimeters. I hope you can still see that one as well. And then lastly, I want the breadth. The breadth is 14 centimeters, and the height happens to be 2. So all this has to just be thrown into your massive scientific calculator. It should solve this in no time at all. Well, from what I'm getting 584 here, 584 square centimeters as our area, the total surface area of this first one. Well, since we would like to compare, let's go and figure out what the area of the triangular prism would be, since you now know how to calculate the total surface area of these two shapes. Well, there is one pointer, though, that you have to pick up about this triangular prism that we've got. Luckily for us, this one here happens to be an equilateral triangle. It means this side and that side and that side are equal. It means also that this side, that side, and this side here are also equal. So you know what? That makes our 3 rectangles equal. What I am saying is, if you look at this rectangle now, this one, right here, and the one at the back, which I am going to try highlight with this color. I hope you can see it. This rectangle here. They practically have the same area now, including the one at the bottom, which is this one here. They will now have the same area. The fact that those 2 triangles are equilateral, it actually makes those 3 rectangles equal as well. So at this point, I want you to figure out that if we want to calculate the total surface area of the triangular prism, we are worried about 2 identical triangles plus 3. This time they are not separate like what we did in our examples. They are actually of the same area. So we are simply going to calculate the area of 2 rectangles, and rather 2 triangles and 3 rectangles that are identical. So our life is a bit simpler this time. Let's just see if we have everything that we need first. So normally, if you're calculating total surface area, you will go ahead and say, if it's triangles, you know, you say half base times height. You just have to pick the base and the height of a triangle. And then if it's a rectangle, you just go ahead and say length times breadth. You just have to know the length and the breadth of these things. So if you're looking at this, you are seeing that I actually have the length and breadth of the rectangles. At this point, this side, I'm sorted this side. The length of these rectangles will just be this longest thing, which is 22. And then the breadth thereof, look at the one at the bottom, you see, to have 22 and 4.5. And it will be 3 of them, like that. So I have no problems on the rectangles. However, on the triangle, notice I can go and say 2 and say half here perfectly. Now when I try to say half base, which is this one, when I try to get the perpendicular height of these 2 triangles, then I can notice that I don't have it. I don't have the perpendicular height over there. So it calls for you to do some work a bit here. So you will have to be forced to draw. Let me extract that triangle so you know what we are talking about. So this is the triangle we have there. And from what we heard, it's 4.5 everywhere, okay? You know what? Let me do it at a place where there is enough space. Okay, we have an equilateral triangle. Why don't I take advantage of the fact that I have an equilateral triangle here? Okay. Okay, perfect. So now that I took that equilateral triangle, I just put it there. So from what we heard, this equilateral triangle, the cross-sectional area, has got a length of 4.5 centimeters. That is what we know. It's 4.5 here, it's 4.5 there, and it's 4.5 centimeters down here. What we don't seem to have is this distance from there all the way to here, where this is a 90-degree line here. So we would like to know the height of this triangle right here. I think you can see what we are going to do. We are actually going to do Pythagoras here, because what we are going to do is to notice that this one and that one should be equal. And since it's an equilateral, there are two ways of doing it. It means there is 60 degrees everywhere, 60 degrees here as well. It's an equilateral triangle. So I can do it using trigonometry to calculate that h. How will I do so? If you have done trigonometry before, you will notice that h, this h here, is the opposite of 60. So I have the opposite and the hypotenuse. From what you know in trigonometry, if you have the opposite and the hypotenuse, then you can say sine 60 is the opposite over the hypotenuse. Don't worry if you haven't done your trigonometry in a while. It's fine. I will use Pythagoras just now, but this one was just going to be better, okay, if you remembered. So this is what you do. If you use this method, you will get your height. It's actually some 9√3/4. So I'm going to just write it as let me write it as 3.90 here. Okay, 3.90, that would be in centimeters then in this situation. But no, let's do it using Pythagoras. Let's say, or how else can we calculate that very same height that we have here? From what we just gathered, okay, from what we gathered, we need to also use Pythagoras. To use Pythagoras, I'm going to ask you to extract this triangle here in your head, thus 4.5. We would like this side over here, and we have to take half of 4.5. Half of 4.5 will be 2.25. Then we do Pythagoras using this. So if you are doing Pythagoras, I think you can notice that, Pythagoras is like this. You say x squared plus y squared. That's Pythagoras, where r squared is the hypotenuse. So we'll have 4.5 squared here, and then our x squared happens to be 2.25 here, plus 2.25 squared, not raised to the power 5. 2.25. Let's square it, and then we say plus h squared. So now from here, it is really a matter of you doing what's necessary here. So you can calculate your height. So it's very simple. Let's just go ahead and agree that it should be 3.90 at the end when you do everything that's required. Okay, so you just have to subtract 4.5 squared minus 2.25 squared and get the square root. Now that I know that my height is 3.90, whichever method I used, I can now go back. You see, now I'm going back to this, and now I'm going to finish off what I started. I want the area of these two triangles here, so I know it's half base times height. Now I just gathered the base of these triangles is 4.5, and the height, I just finished calculating it as 3.90. Normally, I prefer using the exact answer that I have, which is 9√3/4. Okay, so this is what you will have to do. So to calculate the total surface area, only these steps will be required. So I think from here, you should find it's easy to do. This one, if you use your calculator wisely, it should give you 17.54, and this one over here should give you some 297. So the final answer for total surface area for this thing is 314.54. We're going to stick to this one. Right. Remember what the question asked. Which one will be the least expensive to wrap? Now, as you can see, the one with area that is less than the other will be the better one. So in this situation, 314.54 is definitely smaller than 584 centimeters, square centimeters. So therefore, we will pick the triangular prism for this question. So it will be the triangular prism. That's easier. So that is what we are going to pick in this question, and we are going to carry on then. I talked about a cylinder a few minutes ago. I hope you still remember. Let's go ahead and answer something about a cylinder before we go. Because a cylinder is also one of those prisms that we have. I call it a prism because it has a circle at the bottom, and as you can see, it still has a circle on top. So that's one thing that makes us think this thing here is actually a prism, if I must. So you see, the area of this thing, you need to understand it, because maybe you understand it better if I show you maybe that a cylinder actually has got a net like this. This will be the circle, and then the curved part can form a rectangle like that. Okay? And then we will have another circle at the bottom. So it is very simple to calculate the area of a circle. You already know it's pi r squared, and this one will be pi r squared. The thing is, if you want to calculate the area of a rectangle, you have to say length times breadth. The problem is we will never be given the length of a cylinder. There is no such thing. We talk about the height, we talk about the radius, so we need to be able to express our length and breadth in terms of height and radius. So how do we do that? Luckily for us, we can easily see that the breadth is in place of the height. That's a very simple task. And don't forget this part here, this side, which is the length. When you fold it back, because this is the curved part, when you fold it back, it just goes round on this circle right here. So in other words, this length here, which is L, happens to be equal to the circumference of the circles that we've got. And from what we know, the circumference of a circle can easily be calculated by saying 2 pi r. So if you really want to calculate the total surface area of a cylinder, you have to take the two circles into consideration, which means you say 2 pi r squared. And then you take the rectangle, this one, into consideration. You're going to say length times breadth. The length happens to be 2 pi r, and the breadth happens to be equal to the height. So I prefer you think of it, you leave it here. Of course, I know you feel like factorizing 2 pi r. Yes, you may go ahead and do that, but I prefer that you know it this way. Why is it that I want you to know it this way? Well, at times it's a glass which is open on top. It's a can which is open on top. So if it's open, you don't have to include the area of two circles. You have to put one now. So for example, here you already have it on your notes. Look, I gave you the area here for the one that is closed. So this circle and that circle will be available. That is when we use this formula as a whole. But if the top or the bottom is open, then you only have to say pi r squared using just one circle. And you know what? At times you just have a hollow thing. It could be a pipe. So if you have something of that sort, then you only consider the curved part of the cylinder. So it will be 2 pi r h. How simple can anything get? I am noticing that we have to calculate the surface area of this cylinder over here. So let's go ahead and do it. So to calculate the total surface area here, let's assume that it actually had all the surfaces available. So if all surfaces are available, is 2 pi r squared plus 2 pi r h, right? So this is what I said you must do. So you make your substitutions. Watch out, they are millimeters and centimeters. So if the question asked you to put it in square centimeters, you should obey that. So firstly, you are moving from millimeters, you would like to go to centimeters. From what we said, if you're moving that way, if you're moving in that direction, you have to divide. So you have to divide by 10. So it means these ones right here are 9 centimeters. But that on its own is the diameter, you see, of this cylinder. What we want happens to be the radius. So the radius is actually just half of the diameter. So let's put the radius there as 4.5. Okay, I think you're sorted on that one. So it's 4.5 centimeters. I'm going to make your substitutions now. Let's put 4.5 here. And then 2 pi. Our r is still 4.5. And the height, I hope it is in centimeters. Yes, that would be 5 over there. Well, if you use your calculator wisely to actually calculate this, let's see, go ahead and get it. Okay, I'm getting some 268.61. 268.61. That's what I'm getting there, square centimeters. So we've got these. I hope you have the same one as well. You know what? Just so you can understand as well, let me just say this. What if it was this situation here? You know, if it was open on top, if the top was open, or maybe the bottom was open, one of the surfaces was open, how are you going to calculate the total surface area? I hope you heard me. You remove one of the circles, you only have one. Okay, and then you say 2 pi RH. So it's that simple. Life is supposed to all the time be that simple, especially if we are doing math. So let's not forget that our radius was 4.5 here, and then 2 pi, it's still 4.5, and our height happens to be 5. So make it a point that you understand this one. So if it's open, if one circle is not there, so it's either it's open on top or maybe the bottom. So this is how you will get it. Right? From what I'm not saying here, I have 204.99 square centimeters. And lastly, just to make sure that you understand, what if it is hollow, completely hollow? It means it's open on top and at the bottom, this situation that we have here. Notice your area will just be 2 pi RH. It means your circles are not there anymore. You're just talking about the curved part. And this is as simple as anything can get. Our radius here happens to be 4.5, and we still have our height of 5. Calculator work. This is a 5, by the way. Well, it does look like it's 45 pi. It's an easy one to see that one. And then we get our 141.37. Okay, good. So this was, I hope, good revision of things that you already knew. So let's now go ahead and talk about new stuff when we talk about pyramids, the right pyramids in our next lesson. Thank you very much for watching this video. Let's go to the next one quickly.